Hi, I'm John Brooke. I'm here with Eric Herschthal and Jed Kaplan. We wrote the chapter on climate change and commodities in this massive volume. Thinking back in April of 2019, John Curry Machado asked me to write the chapter on, there's a quote, chapter on climate change, combining a relative case study from your own research, along with a more general discussion of the subject and the latest scholarship relating to this. And I think we did actually pull it off. I invited Jed, a climate scientist who's done groundbreaking work on prehistoric and historic land use emissions, and Eric, a rising star in slavery and abolition, to join me in the venture. Um, I think we more or less pulled it off. Um, Rather than asking about climate change, natural and anthropogenic impacting the production of commodities, we focused exclusively on the impact of commodity production on the origins of modern climate change. And I should point out that most scholarship focusing on the Anthropocene will tell you that industrial emissions are the cause of all the problems. We have an argument here that in fact land use emissions were very, very significant well into the 20th century. More than half of the total carbon emissions for that are pressing on the atmosphere. So our contribution was to talk about the impact of commodity production. Now, I've been thinking about this for a few years and explored the proposition in a book and a follow-up article. The proposition that the carbon emissions from land clearance and agriculture were launching the beginnings of the early modern Anthropocene. We wanted to explore the role of commodity production in this early modern Anthropocene and what is broadly now called the long acceleration. Our case study focused on making a first estimate of land use emissions and their impact to sugar production in the West Indies. The result demonstrated that sugar production was clearly exceeded British industrial fossil fuel emissions until roughly the 1770s. Sugar emissions from sugar planting and production, which meant a lot of burning actually, exceeded industrial emissions into the 1770s. And as we moved into the 19th century, the land use data now available from 1850 forward, done by climate scientists, which is based on population, but also census measured cropland expansion, shows that settler societies, the US, Canada, Australia, Argentina, New Zealand, occupying vast regions of the globe, were far and away the highest producer of land use emissions. Presently, the carbon economies in the tropics, like Brazil and Indonesia, lead the world in land use emissions. So commodities matter in terms of climate change over the long term. And so this project is leading us, each of us, into new projects. And I'm rewriting my book, The Rough Journey, and building the argument. As high as they were, carbon emissions from sugar were dwarfed by those from refining of silver in Latin America. Nevertheless, silver emissions were far lower than the ancient and growing carbon equivalent emissions from methane coming out of rice agriculture in China. These emissions, the Chinese rice emissions, were in turn exceeded by the 1840s by carbon emissions from agricultural expansion in the United States alone. The problem that Eric has been devoting a lot of time and attention over the last few years. Let me hand it over to Eric.
Thanks, John. I just want to add what my research has been looking on, inspired by John and Jed's invitation to co-author this. I've been looking and thinking about, as a historian of slavery in the United States, the role that slave-based agriculture may have played in increasing these land use emissions. And the research that I'm working on, and me and John have since co-authored an article on colonial American slave-based commodities and their carbon impact, is the question that a set of kind of interdisciplinary scholars in the humanities and scientists have been posing since the mid-2010. and mid 2010s. And their general kind of discussion revolves around the question that it's not actually the Industrial Revolution or this kind of urban-based 19th and 20th century economy that really gets the whole climate change story going, but that it actually goes deeper into the early modern period. And that really, theoretically, that we should understand the processes of slavery, colonialism, and capitalism, early modern capitalism, as kind of central to the origins of climate change. These scholars have multiple names for this theoretical framework to critique the kind of very modern-looking 19th, 20th century fossil fuel-oriented Anthropocene, and they call it the Capitalocene, the Plantationocene. And while it's rich theoretically, the one thing that I've been troubled with, and what working with John and Jed has helped me to think through, is maybe there's a way to actually test in a more kind of hard-nosed empirical way the carbon emissions of slave-based agriculture, at least in the United States, and compare it to non-slave-based commercial agriculture in the United States. So I will briefly share with you some very preliminary results. But before I touch on that result, the other contribution that I think this research has inspired me to look at is kind of look a little bit more critically at the existing historical land use models. There's a handful of them, and these are what kind of many scientists and scholars who are thinking about historical emissions look at. And their focus, all these models have the fundamental assumption built into them that prior to the 1850s, where the data begets more explicit, that that these are subsistence economies. That is to say, they are not commercial economies. So the land use models are basically assuming every per capita, every person needs a certain amount of food, and based off of the different type of agriculture they're doing, that's all they're growing for. Well, if we're thinking about commodities, we know, certainly historians of slavery, that enslaved people are producing not only enough to feed themselves, but over and above subsistence, commercial or capitalistic commodities. So what I'm trying to do, and what me and John have done in a separate paper, is measure what is the emissions of American-based commodities. And the main ones in the colonial period are tobacco, rice, and sugar, if we're including the West Indies as part of colonial America, which it was. And how does that compare to non-slave-based commodities that were exported? That includes, for example, the commercial wheat farms of Pennsylvania, the livestock growers in New England, et cetera. And it turns out, John and our results show that slave-based commodities, sugar, tobacco, and rice, emitted roughly 4 times more carbon over the period from 1700 to 1775. That's when slave-based labor was used for all those commodities. 4 times more than all the commercially grown family-based labor, wheat, livestock, timber, even to build the ships, etc. So the point is, during this kind of, we can call it a short 18th century, slave-based commodities are clearly the dominant force of land use emissions in this 18th century. And these are, again, emissions that are not included in the existing emissions model. And the last thing I'll say is now I've started to look at a period that in American history is called the early Republic and antebellum periods, roughly 1790 to 1860, and measure the big enslaved-based commodity, that's cotton, and compare it to, ultimately I'm going to build a model for all the slave-based commodities, or at least the largest ones, as well as the free labor ones based in the North. But so far, I have preliminary results for wheat and cotton, wheat grown by family farmers in places like Ohio, Indiana, et cetera. And here too, cotton over the period from 1790 to 1860 is emitting roughly 66% more emissions than all the commercial wheat grown in all of the northern states. So that is, again, if we're just thinking about comparing slave-based emissions to family-based commercial agriculture, slavery is clearly a huge factor in the American emissions. And when you're even, the last thing I'll say, and then I'll hand it over to Jed, is that when you even factor in these American slave-grown cotton emissions, which I have roughly as 1.8 billion metric tons of carbon, that's still more than coal, British coal and American coal over the same period, which is 1.5. And keep in mind, now we're already well through the Industrial Revolution. So cotton itself from land use is already way British than coal. And when we're comparing it to the existing land use models, just thinking about those cotton emissions, that roughly 1.8 billion, that adds 20% to the existing land use models that is only thinking about subsistence agriculture, which is, again, what all the existing models do. So the point is we need to be thinking about labor, racialized labor, and capitalism when we're trying to understand the kind of way in which these early modern economies are beginning a process of carbon intensification. And now I'll hand it over to Jed.
Thanks, Eric, and thanks, John. I think that we've come a really long way since Bill Rudiman originally came up with his early anthropogenic hypothesis more than 15 years ago, suggesting that human activity, particularly changes in land use over the Holocene, the last 11,700 years of Earth history, really changed the global environment and climate. And one of the things that I learned from this study that I found so enriching from this study was working with historians, going back to primary and secondary data and refining our estimates of carbon and greenhouse gas emissions through anthropogenic processes. That's something that we didn't have when we came up with the first estimates of historic and prehistoric greenhouse gas emissions as a result of land cover change. So this is a really model. This study has become a model for what we can do to refine and improve our estimates of greenhouse gas emissions in the past. And what is very clear we're learning is that even our most enthusiastic estimates of how much carbon might have been emitted by humans before the Industrial Revolution might be underestimates. And I think that what we will see in the next few decades of research is improvements and refinements to these global budgeting of carbon emissions that show very clearly that humans had a very big impact on the global environment centuries to even millennia before the Industrial Revolution. And that's something that's really new that's emerging from this research. One thing I wanted to say when we talk about how we construct these emissions inventories is that we take into account when we have agricultural land use, not only the initial release of carbon that comes from deforestation, but also the continuous loss of carbon that comes from a system through crop rotation, of loss of carbon in the soils, soil erosion, and so on. And so these are factors that we try to account for in the land use accounting that we do. The other thing that I think is important to keep in mind is that we account for the way that land use expands not only into forested areas, but also into grassland areas like the interior of Australia, the bush of Australia, or the Great Plains of North America. And we realize that those types of land use transformations from, say, a grassland to cropland also lead to large-scale carbon emissions. When sod is tilled, sod that was formed by natural grassland is tilled to make space for crops, there's a significant amount of carbon that's released and lost from the soil through that system. And if that land is continuously cultivated, it doesn't go back into the land system, but stays in the atmosphere. Finally, I would mention that in building these inventories, we also take into account things like crop rotation, the idea that soils can be exhausted if you grow the same crop over and over time. And so the area set aside for growing crops, or the area required for growing some of these commodity crops over time, when we think about decades to even centuries of land use, requires much more land than the actual land required to, say, produce 1 ton of cotton in 1 year. Because you think that after a certain number of years, that soil is going to be exhausted, you need to move to another place to start growing that cash crop. That requires additional deforestation and so on. So I think that this study has really shown what we can do when we collaborate as an interdisciplinary team of historians, natural scientists. It shows how well we can do when we start focusing in on particular regions that have good data. And it serves as a model for the future of how we can really improve our estimates of carbon emissions during the pre-industrial world.